Welcome everyone. Thank you for coming to Connecting to Azure and O365 using ExpressRoute, and we'll also do a tick overview. I'm James Walters. I work on the Azure Government Engineering team, and my focus is our networking technology as well as connectivity.
And I'm Scott Thompson. You may note that your program said that Susie Adams, our federal CTO, is going to be up here. I am not Susie Adams, but I am a cloud strategist in our federal civilian healthcare business, and I'll be talking about the tick portion of things today.
Excellent. And again, so a lot of you have probably been to some of the different Azure government presentations. So if you haven't, this might be new to you. If you have, bear with me. So we're going to do a slight Azure government overview, just to level set for everyone. Then we'll follow up with, go right into ExpressRoute, and then hand over to Scott for the tick overview. So again, what is Azure government? So click, there we go. So Azure Government is an offering that we have created that is physically separated from our commercial offering. So this has dedicated physical networking and infrastructure just for state, local, federal government, or anyone that has impact level 4 workloads. We have screened US persons in these environments, so you're guaranteed at least you have some confidence in the level of people that are working in there. And all the data residency is within the continental United States. That is probably the biggest differences between that and our commercial offerings. Obviously, there's going to be, we'll talk a little bit about compliance in some future slides. Within Azure Government, we have 100% of the federal cabinet agencies using our services. We have all 50 states, state and local governments represented within the cloud. And just to give you a scale, so even though this is Azure Government, Azure in general, we're pretty large. We have 38 regions worldwide. So where this might be interesting to you is if you have partners or mission owners in, outside of the US, there's multiple connectivity points or places there for data residency. So we have 2 existing regions today in over in Virginia and Iowa. We're building 2 DoD regions specific for the IL5 workloads. And we have announced 2 new regions coming online around April in Phoenix and Arizona to expand our presence further out west. Now, just as a quick overview, this is all of our current 6 ExpressRoute locations. We're going to dive into this deeper in a little bit. And as I mentioned, compliance, the main line we're going to focus on here is line 2 under US Gov. So we have FedRAMP Moderate, FedRAMP High, obviously just an impact level 2, 4, and 5. With CJIS, we have the CJIS agreements in place with 24 states. And with our FedRAMP, not only do we have FedRAMP for the Azure Government, but one of the things you have to be aware of is every service you put into the cloud also has to go through that same FedRAMP compliance. And what that means for you is all the innovations we're putting into this cloud, we're taking the time to actually go through the process to have it compliant for you. So you should feel confident when you spin up at your resources, you're going to be running on a compliant cloud. We covered the DoD, so for the DoD mission owners, we do have the impact level 5 again for Office 365 and Azure. And recently, within the past couple of months, we released the marketplace. And what's cool about the marketplace is it's really open to all vendors or platforms. So this is where you might go in there and get like a Cisco CSR or a Barracuda device to set up into your IaaS environment. And another great thing about Azure Government is one thing, we're heavily invested in this environment. We're not just building it, letting it sit for you guys to use. We're actually building this and continually innovating with new features. So just within the last 3 months, we released 100 features within the GovCloud environment. Now with compliance, we actually started a new program called Blueprint, and there's actually a session that a guy named Nate Johnson will be doing later today talking about ATO and the ATO process. So I highly recommend attending that if you're interested in the compliance. So what Azure Blueprint is we're helping you get through the paperwork to ensure that when you deploy into the cloud, you have your ATO or your compliance solution. So more information on Blueprint can be found at these URLs. And in general, more information about Azure Government can be found at these URLs. Excellent. All right, so let's talk about ExpressRoute. So there's a number of ways to connect into the Azure cloud. So first and foremost, you have obviously internet connectivity where you could access your workloads via that methodology. We have point-to-site connectivity, and we have site-to-site VPN connectivity. But what we're really going to dive into here is the ExpressRoute private connectivity, which is really creating a private dedicated circuit from your on-prem directly into the cloud. So what does this look like? So ExpressRoute allows you to extend your WAN, avoiding public internet and going directly into the cloud. By doing this, we give you predictable performance because since you're not going over unknown route paths or unknown wherever internet pathing, it's just straight point to point. Intrinsically, there's more security with that because you know the line that you're providing is going directly to Azure, it's going nowhere else. You get high throughput. So ExpressRoute can scale anywhere from starting at 50 meg all the way up to 10 gig. If you need more, we can talk to you. And we find that ExpressRoute is a much lower cost option for this high bandwidth throughput comparatively to some of the older connectivity technologies for WAN, such as Sonnet. All right, so selecting ExpressRoute location. All right, so with ExpressRoute, the key is to find the closest Meet Me location to your facilities. And the reason why you want to do that is we advertise our BGP routes equally across all of our sites. When you get on, you want to get onto the Microsoft network as quickly as possible because we're highly route optimized for any of the Azure or Office 365 workloads. So here's our current map of what we look like for our Office 365 and Azure government data centers. When you add in ExpressRoute, we have ExpressRoute all the way from the East Coast covering now the West Coast with Silicon Valley recently going live. In April, we're going to announce these two new government regions, again, Phoenix and Arizona. And later this year, we're going to also provide ExpressRoute connectivities at these locations. And again, the big providers, so we've partnered with Verizon, AT&T, Level 3, and Equinix as the premier providers for the ExpressRoute connectivity. And if you're interested or need to use a DoD cap, we are currently connected to the DISA caps in Ashburn and Dallas, and very shortly we will be connected in Silicon Valley. All right. So the ExpressRoute traffic options. So what you're looking at here is a high-level diagram of what ExpressRoute connectivity looks like to consume Azure resources. On the bottom line, you'll see the light blue, which connects to the Azure IaaS infrastructure. So that's going to be like creating your VNets, your VMs, storage, networking. The middle peering is connected to the Azure PaaS. So this is going to be connected to like your traffic manager, Active Directory, SQL Server. Now these peering types on the bottom we call it private peering, in the middle we call it public peering. And if you're so inclined, we also have connectivity directly to Office 365 to consider our SaaS offering. And this is both for Office 365 and CRM. And we call this Microsoft peering. And to give you a conceptual diagram of kind of how we've separated Azure Government for the Azure Government or the DoD workloads. As you can see, inside the boxes we have the DoD regions called out as well as the just regular Gov regions. The biggest difference here is one's an impact level 4, FedRAMP High, the other one's impact level 5. All of our government regions are built out to the same impact level 5 guidelines. The biggest difference, again, is not the physical separation of hypervisors or storage. That's the big difference you get with the DoD. But for the DoD regions, only DoD customers are allowed in there for now. And again, a further diagram showing the isolation of how we isolate you through VNets. So you go through the VNets, you set up your subnets, put your VMs in there, and that provides you direct isolation directly to ExpressRoute when you extend your on-prem into the cloud. All right. So service provider, so this one can get very complicated. So we have a number of service providers already onboarded directly to provide you ExpressRoute connectivity. We named a few, the Verizons, Level 3s, AT&Ts, the Equinix. But it largely comes down to generally what contract do you have already in place with which carrier, as this is usually the easiest way or easiest path to go, as new acquisitions for contracts with carriers could take months. Now, with that, it's also important to look at, do you already have connectivity with one of these providers on campus or on site? Because what we found is if, for example, if you're using an AT&T MPLS network or NetBond, and you already have the connectivity in place, it's rather quick and easy to get into the ExpressRoute since connectivity is already there. If you do not and you choose to go with AT&T, it can take months to procure the circuit for them to actually run it to your on-prem environment. Another key is, so ExpressRoute is very dynamic in the fact that you can start out with a smaller circuit, like you mentioned. You can start out as maybe as little as 50 megabit and scale up from there. Check with your service provider and make sure that they can also dynamically do this for you. As of right now, I can't think of anyone that doesn't, but you want to verify that with them, so that as you scale ExpressRoute to meet your needs, your service provider can as well. Now, we have a number of connectivity options with ExpressRoute. So we're going to talk about a Layer 2 connectivity solution right here, and I just listed out Level 3 as an example of who provides this for us. Now with Layer 2, that puts some onus on you or the customer to actually manage and run some of the networking gear, as you probably have a networking team on staff or on site to extend into the cloud. Any of the other, besides Level 3 who's directly connected as Layer 2, there's a number of other folks that are connected using the Equinix ECX solution, such as Zayo, Comcast, Time Warner. You could use any of those to connect through. So with Layer 2, again, if you already have an own networking team in place, you have a massively skilled network, this is a great solution for you. Because generally, since you've already put the resources there, we find that the connectivity is generally at a lower cost. Because again, you're offloading or managing the network on your behalf. You definitely have more fine-grained control because again, you own the equipment. And again, cost-wise, since you made the investment in the folks and the equipment already. So then we have what we call Layer 3 connectivity. And this would be your standard like Verizon SCI services, your AT&T NetBond service or MPLS networks. And typically if you already have one of these in place in the cloud, this is really easy to just extend over. In fact, we've seen people get over as little as a few days to connect over to Azure successfully. And that's just going through the process of creating your keys and binding the circuit to your VNets. Now, with Layer 3, it's kind of the opposite of Layer 2. So this is really great for folks that do not have an investment in network teams, do not manage your own equipment, completely want to outsource all that to one of these providers. AT&T or Verizon puts a lot of value add on some of their service offerings as well as like additional security or some packages. But just for straight connectivity, we generally find this to be a little more expensive than the Layer 2 solutions. And finally, we have co-location. So you saw the ExpressRoute locations around the United States. So currently, those are all in Equinix facilities. Now, if you happen to already have a presence in Equinix, it's very, very quick and easy to connect over to us at actually really low charge because you're just basically going to pay for a cross connect. Now, with this, again, if you manage and have gear already co-located in here, great option. This is also great for if you maybe extend like your, let's say you have a NetApp device that you want to put closer to the cloud, you can get a cage there, put that in there, and you get lower latencies, quicker performance for your NetApp or whatever devices that you bring into the co-location model with you. And again, this solution is definitely the easiest and quickest way to go. Again, you already have a presence, and it's just a matter of a cross connect. All right, so data and billing rates. So ExpressRoute has a number of ways. So there's multiple ways to get charged here. So there's an NSP charge, or the service provider charge, which we don't control. That's between you and them and their contract. But obviously ExpressRoute has a charge as well. And you can look at it as a number of ways. First, if you look at it kind of like an unlimited data plan or a limited data plan. Unlimited data plan, meaning you have unlimited data in and out of the Azure data center. Limited, you have unlimited data in, but we charge you a small fee per gigabit out. So depending on how you're using the cloud or how you're doing transferring of traffic, the limited data plan might actually save you a lot of money because it's actually much lower cost to get into, as you can imagine. And with any of these plans, if you start out with, let's say, limited 1 gig or 50 meg, you can easily, without touching the circuit, upgrade. It's a very simple, very simple PowerShell, or I don't think it's in the GUI, but in the PowerShell, you can scale it up as needed. What we find is a lot of the folks are starting out with actually 1 gig, as most of we find our agencies are using Azure and Office 365. Now, if you start out with, one thing to think about this, if you start with a 10 gig or too high of a connection, you can't actually scale that down in a quick, easy way. You actually have to rebuild what we call the application gateway, which binds ExpressRoute to your VNet. So definitely start small and scale up as needed. So some redundancy options with ExpressRoute is, so first there's a number of ways to do this. You can do this with a number of different telcos. You can do this with going to a number of different sites. By default, ExpressRoute forces all telcos to bind with 2 circuits. So you always will have an active circuit, which actually will give you, in theory, if you burst, double the bandwidth that you've signed up for. So if you bought a 1 gig circuit, in theory, you actually have active, so you could actually put 2 gigs of data across that line. So still think about redundancy. You can go with an ExpressRoute, or you can do ExpressRoute coexistence with a VPN backup, though keep in mind the VPN backup does go over the general internet. Option B, which we find most of our customers using, is 2 physical ExpressRoute circuits going to 2 different locations, such as you saw Washington, D.C. or Chicago or Dallas. And then the last one, which I think there's only one customer I know using this, and that's 2 ExpressRoute circuits with a backup VPN. So again, we kind of talked about some of the going through the ExpressRoute selection and deployment process, and working with your carriers or your providers is really key really early on. Because again, we've seen some projects actually almost a year in before they could get a circuit established, just because there was no fiber connectivity there, they had to run it. So if you keep that in mind and you're looking at moving to the cloud, you want to buffer 3 to 6 months of time to establish the connectivity, if this is the way you so choose to go, to ensure success. So we also recommend using System Integrator. We find this being very helpful, as there's a number of things to look at for ExpressRoute. In some instances, we found some customers had some outdated networking equipment on staff, and it was really, or on site, and it was really great about these folks coming in, like an Equinix Professional Services or a Proficient. They were able to identify and redesign their network to be able to consume their to extend their on-prem to cloud. It was not set up for success. Older equipment that didn't support some of the newer things we needed for ExpressRoute. And again, for our connectivity partners, again, Equinix, Verizon, AT&T, or Level 3, These are the contacts to start establishing or exploring ExpressRoute. So you can contact any of these folks and get the process going. So actually with that, I want to open it up to questions on ExpressRoute. Yes?
You just mentioned that there's certain things that you don't do that the partners would note that you don't support that you need. Is there a list or some way we can find out what those are so that we can share them with the appropriate people beforehand ourselves, or is there such a?
There isn't a list per se. So generally, we find we go in there, we go look at their infrastructure, and they don't, and how they've either set up like kind of their NAT or their firewalls doesn't allow actually the traffic to come through properly or at the bandwidth they need. One of the biggest problems we've seen is they'll buy a 1 gig circuit, come through, and they're getting maybe 50 megabit of bandwidth. And of course, that's upsetting because they're paying for this 1 gig circuit. So what happens is these teams go out there, and generally it's a hardware refresh, because maybe they're still using a PIX 535 or 520 from way back when that just doesn't support the throughput that they're looking for. Some of the older Cisco routers, again, it usually comes down to throughput, their NAT design, their firewall design, and how they're really ingressing and egressing traffic from on-prem.
One of the other things you'll find is that occasionally you'll have split path, where if you have two connections, it'll go out one path and try to come back in the other. You need to take a really good look at your environment to make sure that you've got the right address translation and things going on, to make sure that you don't have this in one channel, out the other, because that could create a real problem in terms of being able to make everything work correctly.
Yep. And that's actually a big issue that we see with implementing Office 365. Yes?
Does any of those ExpressRoute solution have a limitation on how many VNets you can connect to?
Yeah, so every one of our services, so the question is limitations on VNets for ExpressRoute. And yes, so we have all of our limitations posted on Azure.com, and depending if you have ExpressRoute or ExpressRoute Premium, which is more relevant to the worldwide deployment, that's kind of what gauges the limitation. So by default, like you can have 10,000 routes on a private. The SaaS and PaaS offerings, meaning the private or the public peering and the Microsoft peering for Office 365 and our PaaS offering is 200 route limit. VNets, I think it's 10 by default, but that can be extended.
Generally, we try to encourage customers at this point not to build a lot of VNets, but to build a fewer number of VNets with more subnets inside of those, and you can even use VLSM if you want to. And that gives you the ability to still do filtering and things between the VNets without having to create, or between the subnets rather, without having to create a large number of VNets, which are then managing the traffic between.
Any other ExpressRoute questions? Yes?
Can you talk about like the tick requirement for tracery versus like ExpressRoute?
Okay, so
We're going to hit that in about 2 minutes after we get done with questions.
So quick guidance on that. So one of the things we worked out with DHS with ExpressRoute is since the traffic on ExpressRoute does not go over the internet, it's not seen as needing tick fully, right? But there's a lot of scenarios when you're implementing cloud solutions, especially with Office 365, where tick is absolutely a requirement. And Scott will go into more details about that right after we're done with ExpressRoute. Yes?
I think generally the Office 365 traffic going through the Microsoft peering.
That is correct.
So this is designed specific for the U.S. government, right?
This is. So the ExpressRoute circuit is 100% dedicated for government, is 100% dedicated to government. It's a physically separated network along with our data centers. So it does not transverse our commercial offering.
And it does allow you to carry all three peering types. So you can get to Azure Government Private and Public peering, as well as Microsoft peering for Office 365 Government Community Cloud and CRM Online for government. So all of those can go together over that one link.
So will this option then be available for private organizations as well?
Private organizations.
It is available to go to, if you're a non-government entity, you're not likely to be in Azure Government. the same peering types and the same ExpressRoute model will work with Azure Commercial. So you can go over to a single ExpressRoute link to Azure Commercial, Office 365 Commercial, and CRM Online as well.
Quick question. Is there a way to connect to the DoD impact level 4 services without going through the gap?
No.
That's a policy thing.
That is a policy defined by DISA.
Couple questions. One, are the slides going to be available after?
We're gonna have to find out. I'm not too sure. I know they're gonna be recorded, but I'm not sure
I
about.
think we're happy to make them available.
Yeah.
We're not doing anything here that's sensitive that we can't give to you. We're just not sure what the mechanism is that we're going to get them to you by.
Right.
So we apologize for that.
In terms of using private ISP space, do you allow that? Is that included in one of your schemes here?
Private.
IP space, like customer?
Yeah, bring your own IP.
Right.
Absolutely. So you can bring your own IP into the VNets.
Okay. And then in terms of Office 365 traffic flows, can you segment the traffic so that it never hits the public internet?
We'll talk about that in a couple of seconds when we talk about tick compliance. The vast majority of it does go over this once you've set up the BGP peering, but there are a few things, and we'll talk about how those actually fall in a valid tick use case that work differently.
Any other ExpressRoute questions? Yes.
If you have, let's say, multiple applications, which goes to one ExpressRoute, let's say, also you have some on premises, you're controlling your applications, but you use the infrastructure and service of the Azure. My question is, that ExpressRoute is not going to make any kind of issue because you have maybe multiple applications coming to this ExpressRoute.
So your question is, you have multiple applications on-prem that you're extending into the cloud, and you're concerned if ExpressRoute will somehow limit the bandwidth limitation? No, that will definitely not be an issue, because what ExpressRoute really does is enable the hybrid cloud scenario. So you can keep whatever you need on-prem, use Azure Stack or whatever you might be using. Extend over what you want either for backup, data recovery, or dev test workloads, or whatever you see fit. Definitely no issue. Any other questions? Excellent. So this time I'm going to hand over to Scott to dive into tick.
All right. So who here's heard of tick? Most of you. Okay, that's good. That's a good thing. We're going to do a quick overview of what tick actually is so that we're all sort of on the same page. Back in the mid-2000s, OMB went and looked and realized that the federal government had a gajillion internet connections and that they weren't all managed the same way, and they believed that that was a substantial risk, and chances are they're right. So what they did was design something to allow them to do network analysis and inspection of traffic, both inbound and outbound, to the federal government. Because in many cases, federal agencies are connected to each other or share networks. So the idea is, let's protect those edge points and know which ones are really important for us to deal with and consolidate to those so that we can actually track everything. So agencies were actually mandated to consolidate these, and they have a whole bunch of intrusion detection and prevention devices. You may hear the term Einstein gateways. Those are the things actually doing the inspection and handling the logging and those types of things. And that's effectively what tick is. There's really 3 objectives for what tick is intended to do. Who is on my network, and do I know who they are and how they got there? Who is accessing my network from outside, whether it's a partner, the internet, or something else? And what resources are those going to be able to access? So if you have those 3 things, you have the ability to go review logs or do intelligent threat detection and figure out, hey, is something bad happening on our network? Are we getting attacked? What do we need to do about it? So fast forward a little bit, they put out a version 2.0 of the tick. And at this point, every civilian agency is mandated to go through an OMB approved tick. There are 2 kinds. There are ticks that are run by agencies. Some of those are single in that the agency or the department is large enough that they run their own and they solely for the purpose of serving those agencies. Others will have agencies where they run the TICs, but smaller agencies will then piggyback off of that TIC connection because they obviously can't afford to do theirs on their own. And we also have something that is called MTIPs, which is telco providers that have implemented TIC scenarios and then allow agencies to connect through those where the TIC services are being offered effectively as a service to the agency. So you'll hear some things about different versions of Einstein. I'm not going to go into that too much today because it gets really, really far into the weeds. But basically what DHS requires right now is raw feed information. They want feed information that gives them intelligence and allows them to see what's going on across networks. And this allows them to do correlation across different agencies, which is actually really important if you think about the context of cyber in this day and age. So it is really about the header, the source, the IP information that's going back and forth, and understand who is connecting, where are they connecting from, and how that works. So right after they released TIC 2.0, they had to do an update. The reason they had to do an update is because this new thing showed up called cloud. Well, how do we do that? Because the clouds actually are stuff that we want to connect to that we've put out there. Whether it's our email or something we build in infrastructure as a service, we got to figure out how to use that. So they updated. So it started talking about connection types to cloud service providers. Everywhere you see CSP up here, that's a cloud service provider like Microsoft. And it also talks about guidance around your accreditation boundaries and how those play into what you're going to do with TIC. There's another key differentiator around unrestricted versus restricted access data. If you have a public-facing website that anybody can go to, that is an unrestricted access data scenario. If you have to provide a username and password and not everybody is able to go access it, then it is restricted access data. If everybody can sign up for a username and password, that just means they want to know who you are. It's still unrestricted access data because anybody could go do it and create a Hotmail account 5 minutes before they log in to present that information to it. And then there's also the concept of encryption and encrypted tunnels and what that actually means to your implementation of TIC. So the guidance is that CSPs can be looked at in two different ways, and we'll talk about a little bit about this more in a second. They can be viewed as an external network, something that is outside that you are connecting to. And in that case, you must absolutely transit a TIC in order to get there. Now, a quick side note about the TIC. People think TIC, and you see the logical diagrams that people like me put up on the board, and there's a little box that says TIC in it. It's not that simple. There's a lot of components in this TIC. If you go actually read the TIC 2.0 reference architecture, it's like 90 pages. If you're having trouble falling asleep, I highly recommend it. It will give you a bunch of detail about probably 20 or so different components that are all part of the TIC architecture. Depending on what you're connecting to and the level of trust you have with what you're connecting to, you can use or go around certain portions of that TIC stack. And that's very important to understand when you start talking about connectivity. So just because you must transit a TIC doesn't mean you have to treat your CSP as hostile as a full-blown internet connection that anybody can come access. So if it is considered an extension of your environment, truly, you have issued a FedRAMP ATO for your agency or department, you have an ATO for your internal services in your department, you can technically connect those, if you so choose as an organization, and say that that is simply an extension of our environment. And in that scenario, we do not need to pass through a TIC because we control everything that we've built in there. Most often we see this in infrastructure as a service. I own everything. It's all force routed back. It's my IP space type scenarios. But each organization may choose to view this differently, and we'll talk about that in just a second. So, definition of an external connection. An external connection is outside of the agency's specific certification and accreditation boundary. That's how it's defined by the TIC folks. So an external system is something that lives out there. So the question becomes, in order to use a FedRAMP approved cloud, there's usually a JAB, a Joint Authorization Board, ATO that comes into play, but it's called a PATO. The reason it's a PATO is not because there's more work to be done before it's a final ATO. It's a PATO because each agency or department needs to choose to accept that, which means they review it and they sign on the dotted line, rather than being able to go, wait, but the FedRAMP people said it was okay. No, you still have to review it and sign off on it. So for that reason, the determination of whether a system is considered internal or external when it lives in a CSP is actually on the agency or department and how they view those guidelines. So the view of external is that the DA does not have control over the application or the application of the required security controls that are out there. So if you look at those security controls, how does that work? And I highly recommend that you come to the session this afternoon that's going to be run on the issuance of an application ATO riding on top of a FedRAMP ATO. And that's going to be done by one of our engineering folks who works on the compliance side, as well as one of the engineers that I work with every day who's actually gone through this process with our customer a few times. But understanding that, you've got to figure out where does this actually lie. So the connection could be used to establish that connection with an external system with Azure, with Office 365, and treat it as external, or it could be viewed as internal. And you're going to need to go view this for yourselves. We've seen customers do this both ways. It depends on the customer, depends on their ISO, their CISO, and what is viewed by the leadership of the organization as acceptable risk. So an internal connection is a dedicated, secure point-to-point connection. The idea here is that everything that goes out there must come back. And that's true actually of either scenario, and we'll talk about why that is in just a second. But this must be done through virtual private network technology, and then we get into this discussion about encrypted tunnels, which I'm going to talk about in a minute, and what does an encrypted tunnel actually mean in the context of TIC, because people actually view that two different ways as well. So this creates an interesting scenario, right? Because now anything that is restricted access data has to go through a TIC. Can anybody see where that would be problematic? Can anybody not see where that would be problematic? If you're trying to get to your email and you want to do it through your phone or from home, what do you have to do now with TIC? You have to VPN in. You have to go connect to a TIC first before you can go to the cloud service provider. So if you go back to the NIST definition of cloud service, the ubiquitous access part, not so much. Becomes a little bit harder now. So how do we solve that problem? Well, there is a draft that can solve that problem, and it's called the FedRAMP TIC overlay. One of the things that's interesting about the TIC and FedRAMP guidelines is they're both derived from the same NIST standard, 853. So realistically, if we could go directly to the cloud service provider and meet a merged set of controls, why can't we do that? That would make sense. If you feed the logging information back to DHS, you've got the source and destination information, you have identity information, you'd be able to get what you needed, right? Well, that's the idea of the FedRAMP TIC overlay. So it is a layered set of controls on top of FedRAMP that a CSP must meet in order to be able to provide direct access, and there's a caveat to this, for mobile use cases. Mobile use cases means you can't take your other site that's over in California and connect it directly to the cloud with all 500 users that are there. It means that you can do it for mobile use cases where you have somebody on a phone or maybe working from home or working in another agency or something like that where they need to be able to connect into the environment. So this is not a fully ratified standard. Just want to call that out. We've seen some folks who are very interested in adopting this and taking the risk when presented with the controls. And we've seen government entities that have no interest in this at all until it is a fully ratified standard because they believe there's too much risk that something substantial might change or that it might never get approved. And it's been around for a while, so again, that is a reasonable assumption if you want to make that assumption. But the idea here is that you can generate the audit reports, you can feed them back into your threat intelligence that you do, and they can feed back into DHS's constructs of what they expect to receive relative to TIC logging information. So before I get into specifically how Microsoft goes and deals with these tick scenarios and how it applies to our services, any questions about tick or tick overlay itself? I know I just went through a 90-page paper in about 15 minutes, so who's got questions about that? Yes?
Just a quick comment. The tick overlay was also discussed in the NIST Cloud Computing Security Working Group, and representatives from DHS were there as well. So it's, I guess the people that put out the 800-53 and other items are in the loop.
Yeah, the comment was that the NIST folks who actually put out 853 are part of the working group that worked on the FedRAMP tick overlay. So it's not that there is an intent to do something different or go around. It's really to evolve. And I think that's what FedRAMP tick overlay really is. It's an evolution of tick standards that allows us to do things in the cloud the way the cloud is designed to have them done. Yes?
If you are an agency that's interested in looking at that, is there a pathway to do that?
So if you're interested in looking at the FedRAMP tick overlay, I would encourage you to find, relative to Microsoft folks, find your account team. We have some matrices of published controls. Office 365, we were part of the pilot. I believe we have them for Azure as well. And that will give you the opportunity to do that if you want to look at it. If you don't know who to talk to, please come find us and get us your information, and we'll find somebody to come talk to you about it. Yes?
My assumption is the tick is a stack of different security components. And I don't know what the Einstein fits in, but depending how the stack is designed, is the impact on how impacts bandwidth or?
It does. So one of the things you do need to be cautious about is if you're going to be making a high-speed connection, something like ExpressRoute, through a tick location, you need to have a discussion with the folks that run the tick, whether they're in your agency or a different one, and find out, are they in a position to be able to handle this? Because if the devices that are doing logging can't keep up, you're going to have a throughput problem, and you definitely want to have that conversation as you're doing your planning for connectivity if you're going to pass through tick. And that's where it's important to understand which layers of the tick stack to go through as well, because some of them may be impacted and some may not when you're doing a dedicated connection scenario. Okay. All right, let's talk a little bit about Microsoft and tick compliance. So Office 365, there was a question earlier about what works with ExpressRoute and Office 365 and what is on the public internet. So this slide goes to that point because we'll provide both styles of connectivity scenarios. The main things that you're doing in Office 365, your email, your online protection, that's all of your scanning and everything else that happens to your email, SharePoint Online, OneDrive for Business, Skype for Business, Office Online, all of your identity stuff that you do with Azure Active Directory and the synchronization, and access to the portal all goes over the private connectivity peering with Microsoft. Okay? Now there's a few things that require the internet. We talked about tick use cases just a little bit. Use case one is the publicly available data. So the first thing is actually Yammer. So Yammer we don't have a direct path for right now. So if you're going to use Yammer, you need to make sure that your organization is prepared to take the risk of doing that, going straight over the internet. Now that is all TLS encrypted when you're talking to Yammer, but it's something you want to talk about because it does travel the other path. Office 365 Pro Plus client downloads. Can anybody download Office 365 Pro Plus? Yes, they can. But if you don't have a key, it's not going to work real well. But that's technically something that could be considered a scenario where it's publicly available. So that's not a problem from a tick perspective for that to be coming in over your regular internet connection. Also, DNS and CDN lookups. DNS lookups, anybody can do DNS lookups. Right? Again, it's a scenario where anybody can do that. You can look up where the thing is. It'll return an address. The address it returns now goes over ExpressRoute. So your connectivity is still not compromised. You're going over the ExpressRoute connection to do that. And then obviously external access, if you want to go directly, would have to be through a scenario where you went through the internet, because otherwise you'd have to go back to your tick point and go through first, which would require you to make a connection to the tick. So both of these are available, and when you enable ExpressRoute, you've got the ability to tie in directly if you want to, in terms of using private connectivity, but you can also use public connectivity as well and go over the internet. So that raises the question, can you connect to Office 365 directly over the internet from your agency? If you go through the tick, you need to go through the tick to get there. We all agree to that. And the answer is, it depends on your definition of encrypted tunnel. Some people view encrypted tunnel, TLS, and the algorithms that are used in TLS to be sufficient. It's encrypted. Well, half the time IPsec and TLS use the same tunnels, right? Or use the same algorithms. Or is it IPsec, where it's a tunnel that other things travel through, which, by the way, will also still be TLS encrypted. You can't turn that off. So it becomes a question of, what is a reasonable amount of risk for you? We have a lot of agencies that look at it and they're like, this is TLS 1.2, I sniffed it, I saw it, it's there, I get it, we're fine. We also have some that say, you know what, I actually want an IPsec tunnel all the way out there. And that's where ExpressRoute starts to help you with some of that, because you now have a dedicated connection instead of a connection going through the internet. Does that make sense? Okay. So, all right, so now I'm going over ExpressRoute. How do I restrict access from the internet to my tenant? Because our TIC guidelines say, hey, you have to stop access to your tenant directly unless you choose to be in a position that you want to allow that and have taken the appropriate action to document it and accept that risk. So there's several ways to do that. Exchange Online has what's called client access rules. And these rules allow you to identify where users are allowed to come into the system from. So you're able to restrict how they're able to access. There are also some conditional access rules that work with Azure Active Directory. You need to check and make sure that you have the right agreements in place to be able to use that. But that allows you to say, hey, coming from here, you're allowed in. Coming from here, you're not, right? SharePoint Online has a network location policy, which is in first release now. It should be generally available in the next couple months, I think. And that does basically the same thing that the Exchange Online client access rules do. And then the other thing is if you're using, which you probably should be, ADFS or some other claims-based scenario where you're using your existing, probably PIV card and your Active Directory credentials to log into Office 365, you can implement ADFS in such a way that the claims rules only allow you to authenticate from inside. The other thing you can do is just not publish ADFS outside, which means nobody can authenticate because they don't have a way to go get those tokens, right? So that gives you an ability to lock down the access to Office 365 and make sure that everything comes back internally. I'm going to pause really quickly and make sure that makes sense for Office 365 because Azure works a little bit differently before we move on. Any questions about that? Yes?
See if I'm getting this right, that if you were to use ExpressRoute, what you said, that would be and could be an appropriate way to avoid the tick for Office 365.
I don't know that it's an appropriate way to. You could avoid the tick. I think it's important to note that when you're talking about Office 365, it is a multi-tenant environment. You do not want to do peering and just be wide open to Office 365. You're going to want some sort of firewalls in there. Whether you want to do that in such a way that it is part of your tick stack or next to it is a policy decision that you can make. When we talk about Azure, that's a little bit different because in Azure, you have the ability to encrypt your connection all the way through ExpressRoute or VPN to an environment that you wholly control with your IP space in it. And if you want to totally bypass the tick to do that and it makes sense with your security folks, that's up to you and you can choose to make that decision as well. We see that done both ways. Yes?
So, if the traffic has to do with tick, where do you put your MDM solution in this one?
Good question. So the MDM solution becomes interesting, right? Because how does your MDM solution tie into tick? And the question is not so much about Office 365. That's really your mail. You've really got two options for MDM solutions, right? You've got an MDM solution that lives in the cloud, and you have an MDM solution that lives on-prem. So I don't want to go into the weeds on, because there's a lot of different ways to do MDM, and MDM means a lot of different things to different people depending on what part of it you're looking at. But the challenge there becomes, without overlay, how are you actually being able to be TIC compliant relative to your MDM solution? And it's an interesting challenge. I think it's on the hairy edge of what folks are trying to figure out right now. And if you have a FedRAMPed cloud-based MDM, how does that play in with TIC? And it's going to depend on the provider that you're using and how it works.
So the assumption is that everybody has in-house MDM solution.
Sure.
So a transition period, which is for them, this assumption is that Office 365 is the first path for the going.
Mm-hmm.
So in that case, what do? Do you use a like Intune, or do you use a keep it,
Yeah. So there is no single answer to that scenario, right? It depends on the technology you're using, what you're doing there. If you have one on-prem today, you've really got two options, right? You can enforce the access connectivity stuff that we're talking about. And if you're coming into the environment through your mobile device management and hitting through the TIC to your MDM, you have two options. You can go over ExpressRoute out to it, or you can also go back out through the internet to it. But when you're doing that, you're going to have a NAT/PAT range that is your published endpoints that everything is coming from when it leaves your environment. And because of that, you can then control access to those things and say, hey, I'm only coming from my own stuff. All the people directly on the outside can't come directly. Does that make sense? You're kind of boomeranging through the TIC and coming back out, but that's the wrinkle with the regulation the way it's written right now, and why overlay is ultimately important in terms of helping us be able to get to this. Yes?
I may be jumping ahead, but you can use like a forced path to send the traffic. If somebody comes in connected over the internet to Azure, you can force their return traffic.
Yes. So and that's one of the things about the peering types. They function a little differently. So we started with Office 365, which is honestly the harder one, right? Because it's a public service with public endpoints. And I'll go back to the NIST definitions of cloud again. Software as a service and platform as a service, if you read the definition, explicitly state that you do not have control of the network layer. It's part of the definition. Infrastructure as a service, you do have control of the network layer. And we'll talk about that in just a second, about how you can force tunnel everything and make sure that it comes all the way back through when you're doing it with Azure. Yes?
So I just want to be clear, on your previous slide, you had all the functions of Office 365 except Yammer and DNS going through the public internet.
There's a few CDN things in terms of, if you think about it, when you download something and you use it in Office, you get icons, right? Why would we force icons through that route? The icons are publicly available. So there are things that are in a content delivery network, broadly distributed, so they make the user experience faster. Those will come directly over the internet as well. But I mean, we're talking about logos and pictures and stuff.
So from a purely physical perspective, this is traversing the Microsoft private, dark fiber private network, not the internet at all.
If you're using ExpressRoute, all of the things in the left column here are traversing your ExpressRoute connection, not going over the public internet. That's correct. They're terminating in an ExpressRoute gateway that is part of our Azure Government FedRAMP boundary, and then going from there in the Microsoft network and going over to Office 365. Okay. All right. I'm going to go ahead and move on to Azure here. So when we talk about Azure connectivity, Azure infrastructure as a service traffic is going to have to be tunneled to be TIC compliant if there's sensitive data there. So you can do it with VPN or you can do it with ExpressRoute. Depending on the agency, like we talked about, you may be able to avoid going through the TIC depending on how your agency views that. Is it truly an extension of your network? Is it an internal connection or an external connection? When we talk about platform as a service scenarios, those are generally considered something, or those are something that use a different peering type, a private peering type. So you still have public endpoint scenarios on those because it's not your IP space. Now, what we do have is the ability to restrict access to those, right? So if you implement a SQL database in Azure, it has a firewall built into it. Again, reference your NatPat range that is coming out over your BGP peering, and all of a sudden those are restricted to you. So they're effectively forced back to your agency. They can't get to anywhere else because there's no way for the traffic to go through. And we actually have forthcoming, hopefully later this year, I think towards the end of this year, capabilities where we'll be able to take each of our PaaS services and tie them directly to a VNet such that they will have your private IP space as those PaaS services come on. So that's something that's coming because we know it's important to government customers. But a number of the services today have restrictions that are in place that will allow you to make sure that you're being compliant and not allowing access directly from outside. So I want to talk a little bit about use case 2, because this is basically the picture that describes what it is we need to do with TIC for anything that is data that is non-generally available. Basically, you've got the TIC connected to your environment somehow, and then you have an encrypted tunnel that goes out to your CSP, in this case Azure, and then you've got a remote user who has to come in through the TIC and come back out. So this is straight out of Appendix H. Appendix H, if you're going to go read that TIC reference architecture, start with Appendix H. I know you want to start at the front. Start with Appendix H. It's the part that really tells you how cloud service provider stuff works, and then you can go back in and dig the really hairy stuff later that talks about all the 20 different levels in the TIC. So how do you do this? If we look at use case 2 and how it works with Azure and Office 365, you've got external users and internal users on the network. If you're going to do this in just an internet connected scenario, what you're typically going to do is have everybody inside go out through the TIC in some way, shape, or form and connect to there. Usually when we see VPNs created, they're created from the TIC site. Sometimes folks will create it behind that because they don't have control over the TIC, but you got to make sure that the traffic will pass through the TIC then if you're going to do that. And then from an Office 365 perspective, they come in through the TIC and back out. And the reason they do that is so that they can get that traffic inspection that DHS requires with the TIC guidelines. So in this scenario, you've got IPsec encryption to Azure. You can do that natively to Azure itself. We do have some customers that want more advanced networking capabilities, and we have a bunch of partners who offer things in our marketplace where you can go provision a Cisco CSR router, you can go provision a Barracuda router, and there's several others that are available as well that are in there that give you the opportunity to go connect if you want to extend your infrastructure with what you know rather than just using our gateways. There's some advanced scenarios where if you have differences in static and dynamic routing, you need to go to a more advanced router scenario to do that. And we've seen customers do that, and it's been implemented successfully multiple times. So, and obviously your Office 365 traffic is TLS. So in a scenario where you have potentially a boundary extended type of situation, particularly on the left side of this, you'll see that you have the internal user is now going past the TIC and going straight out to the internet. The two different styles of connections you see here are the two different styles that James talked about earlier. You have the one that is a connection that is over an MPLS style network, like an AT&T or a Verizon, and then you have the ones that connect at a colo data center scenario, something like an Equinix or a Level 3, in order to be able to connect those. So in this case, you can see that the users from outside would come through the TIC and then be able to go out either of those paths. Now this is not intended to show every path. It's intended to show that either of those two styles of connections is available to you. So those are both there if you want to use them, either the colo connected model or the dedicated model. In this case, if you have the co-located model, you actually have the ability to encrypt your traffic all the way up to the co-location point with IPsec, because typically that is agency or department-owned gear, and then you're simply hopping from one side of the data center to the other to go get over to Microsoft Azure through the connectivity that's provided there. So this allows you to be able to access with the dedicated connectivity and give you the path that you need in order to be able to connect to the environment. So with that, I've dumped an awful lot of information, so we'll take more questions. Yes?
Just wondering at that point in Equinix where you're, I guess, hopping across, have you had any discussions with agencies specific to the type of data and the controls that they require? For example, IRS Hub 1075, in one of my experiences, even though it was just essentially going through that particular provider's, a box in a cage and across the wires, it was encrypted end to end. It was being treated as, a disclosure of the data.
So not IRS, but I have seen that exact scenario. And there are those who would view that technically for that distance between there. You may not be TIC compliant for the SaaS services, for instance, right? For IaaS, you can IPsec all the way through, in which case you're considered compliant. Generally, what we've seen is when you can have a conversation not about a regulation, but about an actual risk, that comes around really quickly, especially when you get executives to the point where they understand that something's being held up because a US-owned company with a controlled access data center in the United States with cleared personnel who has a FedRAMP package in process.
That's what it came down to.
Effectively, somebody, saner heads prevail and they go, you gotta be kidding me. We gotta get moving here. We're shooting ourselves in the foot for no reason. So that's been my experience. Not everyone worries about that, but there are some folks who do, and they're not wrong. I don't want to say that anybody is wrong. If you want to go read everything and make sure you understand it, there's absolutely a valid interpretation of what's there. But I think it's really important that you have a discussion with a CISO or a CIO about what is the actual risk we're talking about here and what are we actually trying to mitigate. Because the reality of it is if you get access to that data center, it doesn't matter whether it's TLS or IPsec, you could dump it off to a hard drive and go crack it later using cloud services in your spare time. So it's one of those things where you just got to talk about the real risk of that. Yes?
So if you have a direct connection with the express route, how do you prevent like a single point failure if there's a problem going on with the express route network?
Great question. So in order to do that, and jump in if you want to take this one, but my customer, the way they did is they have 2 redundant links, right? 2 express route connections. And as James said, there's 2 links on each of those. And then they actually, before they took anything live, tested failing both the things on the Microsoft side as well as failing the connections on their side. And they tested to make sure that everything would fail over and handle those scenarios correctly. So I would suggest you do that before you go live with anything.
You could also select several different carriers to be even more careful, right? So if you pick, let's say, Washington, D.C. and Chicago as your meet me locations, maybe choose AT&T for one, Verizon for the other, then you have completely different paths going to different locations.
So on that note, so express route as a notion is more than logical than you're talking about physical diversity.
Yep.
Yeah, and that goes back to the layer 2, layer 3 discussion that James had. And you could even do one of one and one of the other if you want.
Yep, there's physical connectivity involved and there's logical links over that physical connectivity.
I want to change it a little bit slightly. What if it's hand off to like a Verizon and then to express route? And if Verizon has a problem, does that take down the entire?
That's the issue with diversifying with different carriers, because if the SCI network has an issue getting to express route, you're not going to get to express route. But if you have NetBond as a backup or maybe Equinix or something else, then you'll go that path.
And even if you're going to the colo location scenario and you have 2 connections, make your connection to the colo location, make one of them one provider, one of them another provider. So at least your telco provider scenarios coming into those colo locations or meet me locations are different. And that's up to you in terms of how you want to do that.
Yep. And one thing to look at is definitely diverse pathing. So make sure whenever carriers are picked, make sure they're not going along the same path, same road, same railroad. Make sure the paths go down different streets.
Yeah. If the fiber cables are right next to each other, the backhoe is going to take them both out. Okay. Other questions? Yes.
Yeah, I think I got the answer to this yesterday, but I just want to double check. So if you have express route and you have a geo storage replication that's going to another region.
Yes. So that's a good question. Outbound traffic doesn't incur charges. Outbound traffic from you to Azure. Inbound traffic will incur charges if you're on the metered version. In terms of the replication from one data center to another, like with geo-redundant storage, that traffic for that replication is included in the cost of the geo-redundant storage versus the locally redundant storage.
That goes over the backbone.
Yeah, that's backbone. It's not something you need to worry about. And as adjunct to that, just to point out, if you go, there's a standard version of ExpressRoute and a premium one. The premium one includes BGP capability, which means if you have one connection, you're only connected to one data center and you replicate to the other one. If you have the premium version, BGP will allow you to route over the backbone to the other data center through your primary connection. So it'll take that location and use our backbone to get to the other side.
And correct me if I'm wrong, but I do believe it's required if you have O365 in government, you are required to have premium
It is.
ExpressRoute.
That's correct.
Because you saw the data centers before, O365 spread across 5 or 6 different data centers, and how they work, you're not quite sure what data center your mailbox might be in, so that's why you need to be able to BGP to all the regions.
Yes.
So here you are showing that the external user is routed through TIC.
Yes.
However, for Office 365, even that is public IP space, right?
Mhm.
User is authenticated. If you are restricting that to TIC, there's no way to have the other parts of user access go via TIC, because that's going to be outside, right?
So that's and I actually talked about this a little bit earlier. There are some things that we can do relative to Office 365. Where is the mouse? Here we go. We'll get there. Come on. Oh, I missed it. Who was the other one? Yes, thank you. Sorry. So there are some things you can implement that do that, right? So client access rules for Exchange. The client access rules for Exchange will determine where the client's coming from. If the client is coming from outside, it'll block it, right? That way you'd have to go into the TIC first and come out. The SharePoint rules that you see there do the same thing. And when you're talking about ADFS scenarios, if you can't have ADFS process the claims correctly because you're outside, it will reject you and then not give you the tokens you need to go actually do the access to the system. Does that make sense? Okay. Yes?
At the very beginning of your slide deck, you talked about the point-to-site connectivity option.
Yeah, it's like wildly TIC non-compliant.
Wildly TIC non-compliant.
Yeah.
Sorry, was that out loud?
Okay.
It's an option that is available in Azure. It is an option that is available in Azure Government. We have some scenarios where we see customers want to have things like detonation zones, like, hey, we would like to try this software, but we don't want it anywhere near our network. So we're going to go purchase a little bit of Azure, put it out there. We're going to go install this new thing, see whether it works, monitor it, do whatever that is. And they basically say, hey, we're going to go do this out there. And they do a point-to-site, not usually from a GFE or government furnished equipment, to connect to that in order to be able to go do that testing and what's there. So it is a capability of the platform for production workloads until we have overlay, which would allow the coexistence of those two scenarios. Then you'd be in a position where you could use it. Because you could actually have a mobile endpoint, your laptop, working from home, go directly to the cloud to get access to the stuff that's there via the point-to-site VPN. Okay. Yes?
This caps the ExpressRoute co-location zones, or will you still need to go to a unique point?
I'm going to give that one to you.
Sure. So we're currently onboarded the DISA caps. Almost think of them almost like an NSP. So you would need to work with a mission owner to get permission from DISA to establish a circuit over it. So we're permanently connected.
Okay. So meaning you do have
So we're currently they have connectivity in each and those Equinix facilities in the Washington D.C., Dallas, and they're currently working on Silicon Valley. So as long as you get a circuit, if you onboard with us there, you can transverse our current physical connection to the cap, pending DISA approves creating the circuit.
Yes.
Sorry.
It's all right.
Yeah.
That's why we're here.
Okay. This might be a little bit off topic, but in the Office 365 and the Azure ecosystem, if you know, you did 100 deployments or new feature rollouts over the past 3 months. How do you guys keep control or keep the feedback loop going with NIST as it relates to changes to cryptographic modules, for example? So the FIPS 140-2, yeah, there's the long drawn-out process for getting a certain thing approved, but then you can submit incremental changes.
So typically what we do in terms of inclusion of cryptographic modules in our cloud platform is, first off, they're generally hosted in Azure and they are consumed by the other services. So the cryptographic services used by Office 365 and CRM Online actually come from the Azure Fabric. The cryptographic modules that are used in Azure are actually those that are derived from Windows Server. So once Windows Server has its cryptographic approvals, those are then rolled into the cloud services and we can reference those particular certificate numbers for those cryptographic modules. We also do have an HSN that is in play here as well, and that has FIPS 140-2 Level 3 certification and the certificates associated with it as well. I do not have those memorized, sorry. Oh yes, sorry. Pillars like blocking.
Touching on the overlay, is there any kind of roadmap or timeline for when it might ever become a ratified standard or anything like that?
Gosh, I wish.
Sitting out there.
Unfortunately, I have nothing for you on that. I wish there was. I think it was one of those things where there's this event that happened in January that kind of shook up the government a little bit. I think it might have gotten lost in the other thing there. And Nate, I see you sitting back there. If you know something I don't, speak up. He says no, he doesn't. All right. Well, it is, I think, officially lunchtime. And the more questions you guys ask means the longer it's going to take you to get to lunch, and the more picked over it'll be. So thank you very much for your time today. We'll hang out for a few minutes if you've got any additional questions.
No, you guys.